Okay, welcome to the Algebra 1A semester exam review. We are going to cover numbers 32 to 39 in this video. So let's take a look at number 32. It says, Frida is keeping track of how many coupons she has saved on a piece of paper. She spilled some coffee on the paper. Her list now looks like this. Blank represents where the coffee spilled occurred. So she started with 30 coupons. We don't know how many coupons she had after 1 week or after 2 weeks, but we know that after 3 weeks she had 240 coupons. It says assume that the sequence of the number of coupons is arithmetic. Remember that in an arithmetic sequence, the numbers are either increasing or decreasing using addition or subtraction. Okay? It says how many coupons did she have left after 1 week, and then how many coupons did she have left after 2 weeks. So we know she started with 30 coupons, right? That was what she started with. Okay. Then she had some number of coupons left after 1 week, some number after 2 weeks, and then at 3 weeks we know that she had 240 coupons. Okay? Because this is an arithmetic sequence, we know that the number of coupons she had is going up by the same amount each time. So we're going to let that amount be x. So from the beginning, when she had 30 coupons, till week 1, we're going to add x. Okay? From week 1 to week 2, we're going to add another x. And then from week 2 to week 3, we're going to add another x amount of coupons. Right? We can now take this information and put it in an equation. We started with 30 coupons, and now we're adding x plus x plus x. So we're adding 3 x's, okay, and that brings us to 240 coupons. Okay. If I solve this equation, I'm going to subtract 30 on each side. Okay, and we're going to run out of space, so let's go here. I've got 3x equals 210. Divide each side by 3, and x equals 70. So I know I am now adding 70 coupons each week. Okay. All right, so 30 plus 70 is 100. 100 plus 70 is 170, and then 170 plus 70 is 240. How many coupons does she have left after 1 week? She had 100 coupons. And then how many coupons does she have after 2 weeks? She had 170 coupons here. Part B says that assume the sequence of the number of coupons is geometric. And remember that in a geometric sequence, the numbers are going up by multiplication. Okay. Again, it's asking how many coupons does she have left after 1 week and then after 2 weeks. So now let's set up another sequence. We're starting with 30 coupons. Okay. We have some number left after week 1, some number after week 2, and at week 3 we have 240 coupons. The difference between this and the first one is that in the first one we were going up by adding the same number each time. This time we're going to multiply by the same number. And because I don't know what that number is, I'm going to say that number is x. So we're going to multiply by x each time. Okay? I'm going to take this information and put it in an equation. So we're going to say 30 times. Now I've got 3 x's, I'm multiplying that together, so I'm going to say x cubed equals 240. Okay. Divide each side by 30, and I'm left with x cubed equals 8. And now I'm looking for the same number, right? I'm multiplying that same number 3 times to get 8, and that number is going to be 2. Right? I can rewrite 8 as 2 cubed. Okay? So I know now that this x is actually 2. So I'm multiplying by 2 each time. Right? So 30 times 2 is 60. 60 times 2 is 120, and then 120 times 2 is 240. So how many coupons does she have left after 1 week? She had 60 coupons after 1 week, and then 120 coupons after 2 weeks. Okay, let's look at number 33. Okay, it says in art class, students create a project with blocks in a pattern. Students will use algebra to describe the pattern, and a student writes 2 formulas on the board. The recursive formula is f of 1 equals 3, and then f of n equals 2 times f of n minus 1. The explicit formula is f of n equals 3 times 2 to the n minus 1 power. Write the first 5 terms in the sequence. To write the first 5 terms in the sequence, it might be easier to use the recursive formula. The recursive formula tells me that my first term is 3. Starting with 3, and then I need, well, that's my first term, so I need second, third, fourth, and fifth. Now, the recursive formula tells me that my common ratio is 2, which means I'm taking the previous term, which is right here. It's represented by f of n minus 1. That represents your previous term. I'm taking the previous term and multiplying it by 2. So I'm going to do 3 times 2, which is 6. Okay, times 2, which is 12, times 2, which is 24, and times 2, which is 48. Okay. Question B says, you want to know the value of f of 30. Is it more efficient to use the recursive or the explicit formula? Explain your answer. Right? If I use the recursive formula, I'm going to have to start with f of 1, and then I'm going to have to find f of 2, f of 3, f of 4, all the way up to f of 30, which would get really long. So in this case, it is more efficient to use the explicit formula because you can just substitute in 30 for n. Okay, so if I use the recursive formula, I will have to find f of 2, f of 3, etc. until I get to f of 30. Okay, it's easier to use the explicit formula because I can substitute 30 in for n. Okay. All right, let's look at number 34. It says Julio is filling out his tax return. He needs to report the value of a computer that he bought several years ago for $8,192. He has 2 options for doing this. So option A says that the value of the computer decreases every year so that its value is 3/4 or 75% of its value from the previous year. Complete the recursive formula for the value of the computer using option A. So we know that the initial value, okay, the initial value is $8,192. And because it is decreasing every year by 75%, right, we are going to multiply our initial value right here by 0.75. So we're going to take the initial value, multiply it by 0.75, so that'll give us 3/4 of its initial value. So my recursive formula, a of n equals 0.75 times a of n minus 1. So you take whatever the previous value was and multiply it by 0.75. You can also multiply it by 3/4. Keep that 0.75 as a fraction. times a of n minus 1, again, which is your previous value. It says after 2 years, how much will the computer be worth using option A? Well, let's see, I started with $8,192. I'm going to multiply that by 0.75%, well, or just by 0.75, and that will give me $6,144. This is its value after the first year. This is at year 1. Okay, I'm going to take this value now, 6,144, and multiply it again by 0.75, and that'll give me its value after 2 years, which is $4,608. This is at year 2. Okay, so the value of the computer is $4,608 after 2 years. All right, now let's look at option B. Option B says the value of the computer decreases by $1,024 each year. Complete the recursive formula for the value of the computer using option B. Okay, so here's our initial value, 8,192. So I'm going to say B of n equals B of n minus 1, which is its value the previous year, minus 1,024. Okay? This is your common difference right here. Okay. It says after 2 years, how much will the computer be worth using option B? Well, let's see. We start with $8,192, and it's decreasing by $1,024 each year. So at the end of the first year, it will be worth $7,168. Okay. Now I'm going to take this new value, $7,168, and again subtract 1,024 from it, and that'll give me its value after 2 years, which is $6,144. Okay. All right, it says after which year will the value using option A be greater than the value using option B? Complete the table below to answer this question. All right, so remember, option A, you were decreasing the value of the computer by 75%. Decrease by 75%, so by 0.75. So you're going to take every number, multiply it by 0.75, right? And so that would give you 4,608 after 2 years, 3,456 after 3 years, 2,592 after 4 years, 1,944 after 5 years, 1,458 after 6 years, 1,093.50 after 7 years, and $820.13 after 8 years. Okay. Option B, you are decreasing by $1,024. So here you're going to be subtracting 1,024 each time. And so that would give you $6,144 after 2 years, $5,120 after 3 years, $4,096 after 4 years, $3,072 after 5 years, $2,048 after 6 years, $1,024 after 7 years, and then $0 at 8 years. Okay, so it says after which year will the value using compute option A be greater? So it's after the 7th year. The value of the computer using option A will be greater. Okay? Because up until then, option B is actually greater. Right? Okay. 35 says, use the answer bank below to complete the following statements. An explicit rule for an arithmetic sequence would be a blank function. Okay? That would be a linear function. It has a common difference, a constant difference. And if you graph this, you see the word line in linear function, right? So this graph would be a line. Okay? B says the recursive formula f of 0 equals 20, f of n equals 30 times f of n minus 1. That represents a geometric sequence. And that's because we have a common ratio here of 30. Okay? Its explicit rule would be an exponential function. Okay. The sequence 10, 12, 14, 16, 18, 20 has a constant difference of 2. Right, and we see that right here. We're adding 2 each time to get the next number. Okay, and D, the sequence 10, 20, 40, 80, 160 has a constant ratio of 2. And we see that we are now multiplying here by 2 each time to get the next term. Okay. Okay. Number 36, it says an office is interested in how much recycling occurs. On the first day of a month, there were 700 pounds of recycled materials. Each day after that, 80 more pounds of recycled materials were added. Let R of n represent the total number of pounds of recycled materials on day n. It says complete the table for the total number of pounds of recycled materials. Well, each day there's going to be 80 more pounds, right? So we're going to be adding 80 each day. So we started with 700, added 80, that gave us 780. So on day 3, we would have 860 pounds. On day 4, we would have 940 pounds. On day 5, we would have 1,020 pounds. And on day 6, we would have 1,100 pounds of recycled materials. And again, we are adding 80 each time. Okay? All right. It says, on which day will there be 1,580 pounds of recycled materials? Show how you determined your answer. So we need to write an equation here. So I want to know when will the number of recycled pounds of materials be equal to 1,580. Right? So I'm starting with 700 pounds of recycled materials, and I'm adding 80 each time. So I'm going to do 80 times n minus 1, and that's because I'm starting with the first term right here. I'm not starting with the 0th term, right? If I had that, then I wouldn't need the n minus 1, but I do need that here. Okay. So solving a multi-step equation, subtract 700 on each side. Okay. That gives us 880 equals 80 times n minus 1. Okay. Instead of distributing, I'm going to go ahead and divide this 80 out. But you could have also distributed the 80. And let's go up here. So that gives us 11 equals n minus 1. Add 1 to both sides, and you get n equals 12. So on which day will there be 1,580 pounds? On day 12. Okay, and that's our answer. All right. This is write a recursive formula for the number of pounds of recycled materials. Well, R of 1, so that's on the first day, we have 700 pounds. Okay. R of n is going to equal R of n minus 1 plus 80. That's our recursive formula. D says write an explicit formula for the number of pounds of recycled materials. So there's 2 ways we can write this. We can say our initial value 700 plus Here's our common difference. And again, I'm going to do n minus 1 because I'm not starting with the 0th term. If I wanted to start with the 0 term, I would go back 80, right? So instead of adding 80, I'm going to go back, I'm going to subtract 80. And so on day 0, I would have 620 pounds of recycled materials. So if I use that, I can say start with 700. Oh, no, sorry, not 700. Start with 620 and add 80 pounds each day. Okay, let's look at number 37. It says, look at the pattern of small squares below. The number of small squares, n of t, is a function of the number of the figure number, which is t. Right, so in figure 1 we see we have 1 square. Okay, figure 2 we have 2 squares. In figure 3, well, let's see, figure 1 we have 1 square, here we have 2 squares, here we have 4 squares, here we have 8 squares. So we see that the number of squares is doubling in each figure. So A says draw the pattern for figure 5. So I know figure 5 is just going to be double what I have here. So here, since I have 8, I'm going to add 8 more. So let's draw this separately. Okay, there we go. All right, so here I have 16 squares in figure 5. Okay, B says complete the table for figures 1 through 7 for the number of small squares. So in figure 1 we had 1 square, figure 2 we had 2 squares, figure 3 we had 4 squares, and I'm doubling, so figure 4 I had 8 squares, in figure 5 I had 16, double that and I get figure 6, which is 32, and double that and I get 64. Okay, so all we're doubling the number of squares. Okay. All right, it says make a graph for the number of squares. So I know that at 1, I had 1. It's going to be really close to the x-axis. It's going to be really close to 0. At 2, I had 2 squares, so just kind of take a guess where it might be. 3, I have 4 squares, so it's closer to halfway. Okay, figure 4, I have 8 squares, it's going to be closer to 10. Figure 5, I have 16 squares, so 10 and then about halfway through. And then figure 6, I have 32 squares, so here's 30 and then a little less than halfway. And then figure 7, I have 64 squares, so here's 60 and about halfway. Okay, and if I want to know how many squares I have in figure 2, remember I'm multiplying by 2 to get to the next figure. So if I want to go back, I would divide by 2, which means I'd probably at figure 0 maybe have half or something very close to 0. Okay. Right, D says write the recursive formula for the sequence of the number of squares. So n of 1 was 1. Right? We started with 1 square. And then we're doubling, so we're going to say our common ratio is 2 times n of t minus 1. Okay. Write the explicit formula for the number of squares. Okay. Here's my common ratio, 2, and I'm going to set it to the t minus 1 power because I started with the first figure, figure number 1, not 0. Right. F says, is the sequence of the number of squares arithmetic, geometric, or neither? Okay, this is going to be a geometric sequence, right, because there is a constant ratio of 2. There's a constant ratio of 2. All right. Okay, question 38 begins Unit 2, Topic 3. Right, 38 says Joe's Body Shop charges $25 for parts and $50 per hour to fix the brakes on a car. Kathy's Body Shop charges $70 for parts and $40 per hour for the same type of work. So we're going to let X represent the length of time to fix the brakes on the car. A says write an expression for the amount of money that Joe will charge to fix the brakes on the car. So Joe is charging $25 for parts. You're going to have to pay that. That's a one-time fee, plus $50 per hour, and hours are going to be represented by X over here. Okay? B says write an expression for the amount that Kathy will charge to fix the brakes on a car. So now she is charging $70 for parts. So you're going to have to pay that. That's your one-time fee. Plus $40 per hour. So that's 40x. Okay, it says when will the amount charged by Joe and Kathy be the same? Show how you determined your answer. So I want to know, here is the amount that's charged by Joe, 25 plus 50x. I want to know when will that be equal to what Kathy charges, which is 70 plus 40x. And here you have yourself a multi-step equation. So many ways to start this. I'm going to start by subtracting 25 from each side. Okay. That leaves me with 50x equals 45 plus 40x. Okay, let's combine, get our variables together. So take away the 40x from each side. Okay, that gives me 10x equals 45. And last step is to divide each side by 10. And that leaves me with x equals 4.5. So it says, when will the amount charged by Joe and Kathy be the same? At 4.5 hours, they will charge the same. Same amount. Okay. And let's look at question 39. Okay, it says Brittany is planning a party with her parents. After collecting the following information from 2 possible locations, Brittany is meeting with her parents to help decide which location they should choose. So the first is Over the Top Party Palace, which charges $100 for the use of their location plus $15 per person. And the second option is Make 'em Envious Emporium, which charges $300 for their use plus $10 a person. So it says, how will they determine which location they should choose? Justify your answer. Well, the first thing I'm going to ask myself is, at what point are they going to charge the same? Okay, so Over the Top Party Palace, I'm going to abbreviate this, Over Top Party Palace, okay, they are going to charge $100 to use their facility plus $15 per person. So we'll say X, we're going to let X equal the number of people invited. Okay? Alright, so that's Over the Top Party Palace. And then Make 'em Envious Emporium. Okay, they are charging $300 for their location plus $10 a person. So let's see, how many people would you have to invite for these two to be equal? So I'm going to set up this equation, and I'm going to start solving. Subtract 100 from each side. That leaves me with 15x equals 200 plus 10x. Okay, subtract 10x from each side. That leaves me with 5x equals 200, and x is going to equal 40. So I know that at 40 people, when I have 40 people, the price will be the same. Okay. How about if I have less than 40 people? So let's say I have 30 people. Let's see what's going to be cheaper if I have 30 people. So I've got Over the Top Party Palace, and I've got Make 'em Envious Emporium. All right. So for 30 people, I'm going to say 100 plus 15 times 30. Okay. I'm going to have $550. That's my charge, $550. Right? Make 'em Envious Emporium, I've got 300 plus plus 10 times 30, right? That gives me $600. So if I have less than 40 people, okay, over the top Party Palace is going to be cheaper if I have less than 40 people. What if I have more than 40 people? Well, let's try 50 people. All right, I've got 100 plus 15 times 50. Okay, that will give me $850. Okay. And here I've got 300 plus 10 times 50. Right, that's just going to be $800. So if I have more than 40 people, okay, Make 'em Envious Emporium would be cheaper. So I have 40 people, the price will be the same. Okay, less than 40 people. Okay, over the top Party Palace is cheaper, but for more than 40 people, okay, Make 'em Envious Emporium is cheaper. So, okay, what location they choose depends on how many people she's going to invite.